Next one is this. Okay, so a signal is represented by x of t equal to this, so which is nothing but our rectangular function. From where to where? From -1 to +1 with amplitude 1. So this is our x of t. Okay, so we have to find the Fourier transform of which signal? X of 2t convolved with x of t by 2. Okay, so let us do that. X of t is equal to a rectangular function. From where to where? From -1 to +1 with amplitude 1. So this fellow will have what as Fourier transform? X of j omega, which we know to be how much? 2 sine omega divided by omega. So that should be equal to 2 sine omega by omega. Now question is we have to find Fourier transform of y of t. Okay. Yes. So what is y of t here? Y of t is equal to x of 2t convolved with x of t by 2. So how many properties involved? Time scaling and convolution in time domain. So this fellow will have y of j omega as the Fourier transform, which should be equal to x of 2t will have 1 by 2 x of j omega by 2 as the Fourier transform, and this fellow should be multiplied with whom? X of t by 2 will have 2 times x of j 2 omega as the Fourier transform. Both involves time scaling property, but convolution in time domain will bring in the multiplication operation. So this should be equal to finally how much? Here x of j omega is there. So let us substitute that. Okay, so first term is 1 by 2 x of j omega by 2. So wherever there is omega, replace with omega by 2. So this should give you 2 sine omega is replaced with omega by 2 divided by omega by 2, and again this fellow is multiplied with 2 into x of j 2 omega. So that should be 2 times 2 sine 2 omega divided by 2 omega. Okay, yes. So 2x of j 2 omega means what? 2 times x of j omega is replaced with 2 omega. So let us see who will get cancelled. Okay, so this 1 by 2 and this 2 are gone. This 2 and this 2 are gone. So totally this should be equal to how much here? 2 times 2 is 4 sine 2 omega sine omega by 2 whole divided by omega square. Correct. So that should be the Fourier transform of which signal? X of 2t convolved with x of t by 2. Okay, right. So let's go to the last problem, which is this. Okay, for the signal f of t equal to this one, sine 3 sine 8 pi t plus 6 sine 12 pi t plus sine 14 pi t. The minimum sampling frequency satisfying the Nyquist criterion is dash. Okay, so definitely highest frequency is how much? We will put in hertz. So highest frequency. So this corresponds to 4 hertz. This corresponds to 6 hertz. So this corresponds to 7 hertz. So that is the highest frequency. Highest frequency is 7 hertz, and hence minimum sampling frequency, right? So minimum sampling frequency or sampling rate is equal to twice the highest frequency. Okay, it is twice the highest frequency, which should be equal to 2 times 7, which is nothing but 14 samples per second. But he has asked in hertz. So as I said before, they may give the question in hertz, but actually right unit is samples per second. So what is the right choice here? 14. Okay, yes. So that was the last problem in old gate questions. So many are there. So I have solved past 6 years problems from E stream. Okay. Yeah. So remaining problems, if you have doubts, you can raise it. So we can give you the solutions. Okay. Yeah. So with that, we are done with what? Yeah, we are done with continuous time Fourier transform. Okay. So we have seen the theoretical part. We have solved the problems, and we have also solved old gate question. So with that, we are done completely with continuous time Fourier transform. Next, we will move on to the Laplace transform. Okay.